We are going to solve this question from JEC Mechanical Engineering paper 2022 set 1. The question is as follows. Consider a rod of uniform thermal conductivity. Let's make a rod. A uniform thermal conductivity whose one end x is equals to 0. Suppose this is x is equals to 0 is insulated. So this is insulated. And the other end x is equals to L is exposed to flow of air at temperature T infinity. So here convection is going on and the temperature is T infinity or ambient temperature with convective heat transfer coefficient of H, and the cylindrical surface of rod is insulated. So this is also insulated so that the heat transfer is strictly along the axis of the rod. Then the rate of internal heat generation per unit volume inside the rod is given as. This is the heat which is generated inside, like that. So this is at TA. Suppose the steady state temperature at the mid location of the rod is TA. So this is TA. What will be the temperature at the same location if the convective heat transfer coefficient increases to 2H? So let's find out the equation for the temperature. For generation equation is given. What we have to do, firstly we will find the relation between the temperature and the heat transfer coefficient for this question. Okay, so let me write as 1D heat flow equation. 1D heat flow equation with non-uniform heat generation. So equation is d square t divided by dx square plus q generation divided by k is equals to 0. Now we will integrate both the sides. Right, let me write it as integrating both the sides. It will be dt by dx is equals to integration of minus q dot x dx plus c1, or we can put the value for q dot, then it will be minus 1 by k integration cos 2 by x divided by L dx plus c1. Okay, now we will solve this with the boundary condition. So boundary condition is at x is equals to 0, your heat transfer is 0. That means dt by dx will be 0. So if dt by dx will be 0, your c will be 0. Here it is x cos 0. So we can write it as c is equals to 0. Now we will again integrate this equation. Suppose this is equation 1. We will again integrate equation 1. So it will be now t is equals to minus L 2 pi k into minus L 2 pi cos 2 pi x by L plus C2 because C1 is 0. Now we'll simplify this. It will be coming as t is equals to L square 4 pi square k cos 2 pi x by L plus C2. Now we know that at x is equals to L, whatever heat will be conducted will also be equal to heat convected. So what is heat convected? Minus Ka dt by dx at x is equals to L, and it will be HA T at L minus T infinity. Now when we will solve this, so it will be minus k. We will put the value of t here. It will be minus k 1 by k into L by 2 pi, and this will be sine 2 pi L divided by L, and it will be h a t L minus t infinity. So one thing we can say that t at L will be t infinity. So it will be, when you solve this, L square will be 4 pi square k plus C2 is equals to T infinity. So here one thing we know that C2 is not a function of, this is your boundary condition, is not a function of H. So T is only the function of X, not H. So your TA, that is your mid temperature, will be same even if we doubled the H. So here in the option, your option C will be correct because it will remain same. Thank you for watching this video.